This is Mr. Beck Does Your Homework, AP Physics Homework 4.2, question number 5. A child's toy consists of a small wedge that has an acute angle of 36 degrees. So this angle here is 36 degrees. The sloping side of the wedge is frictionless, and the wedge is spun at a constant speed by rotating a rod that is firmly attached at one end. When a mass of 46 grams rises up the wedge a distance of 9.3 centimeters and stays there, what is the speed of the mass? The acceleration of gravity is 9.8. Well, I've got this mass here. It has a gravitational force this way. It has a normal force pointed this way. And that's it. I don't have any friction. I don't have anything else. So between the gravitation and the normal, somehow I wind up with a center-directed force that keeps this 46 grams from sliding up or down. It just winds up steady, moving around in a certain circle. So what I know is that this, I'm interested in a force directed towards the center. So that means it's going to be a component of the normal force. So what I'm going to do is I'm going to split that into an x and a y. So I'm going to get a force in the x direction. I'm going to have a force in the y direction. And I'm going to have the force of gravity. Now what's neat here is that the force of y is going to equal my force of gravity. And my force in the x direction is going to be my centripetal force. And coefficient of friction is 0. So what I'm looking for is the speed of the mass. So I'm looking for v. Now what's interesting is I've got this angle here. Well, this is Fy, this is Fx. If I think about this triangle right here, that'll get me my x and my y. As this were to get lower and lower and lower, as this ramp were to get lower and lower and lower, then this normal force would get higher and higher and higher. So as this angle got smaller, this angle would get smaller. So that must be my theta right there. So I know that the tangent of that angle is going to be my force x over my force y. It's going to be my opposite over my adjacent. Well, my force x is my force centripetal, and my force y is my force of gravity. So I've got tan theta is Fc over Fg. I also know if I multiply by force of gravity, I get that my centripetal force is going to be my force of gravity times the tangent of theta. I also know that my centripetal force equals mv squared over r. So I've got this and I've got this. Well, I can work them together. Oh, let me one more step here. Fc equals mg tan theta. So if this equals centripetal force and this equals centripetal force, I can set them equal to each other. So I get mv squared over r equals mg tan theta. My mass cancels out because it's showing up on both sides. So I get v squared over r equals g tan theta. G tan theta, if I'm looking for my velocity, it's going to be the square root of r g tan theta. So there's my velocity going around that frictionless loop. Gee, doesn't that look similar to a conical pendulum? It's a very similar idea, because now it's the normal force component that's canceling out gravity. Earlier it was the tension component that was canceling out gravity. So there's my speed. Now I know r, or do I know r? I don't know r. Here's 9.3 centimeters. So I have this, and this would be my radius. Well, actually, if it's this way, then this would be my radius, but it's the same as this one. Towards the center of the circle, right? So if this is 36 degrees, and this is 9.3 centimeters, that's 0.093 meters, how am I going to get my radius r, which is here or here? Well, if this is my hypotenuse and this is my adjacent, I know that my cosine of theta equals r over 0.093, my adjacent over my hypotenuse. So if I multiply by 0.093, I get r equals 0.093 times the cosine of 36. So that's my radius. That number has to go in here, and you know g, and you know theta, so you get yourself a velocity.